Here we are, section 5.4, and what we are dealing with are inequalities and graphs, in particular polynomial and rational inequalities. And we are going to be looking both graphically as well as algebraically. How do we determine inequalities? And so here we begin. We've got example number 1, which is a graph. It says use the graph to solve the inequality, and we want to know where is f of x less than 0. Well, when we ask this question, we're simply asking where or when does the graph fall below the x-axis, or in other words, when is y less than 0. And I notice that it starts at -5 and it goes until 1, and then it starts up again at 6 and goes on forever from that point forward. Now, we always know infinity is never enclosed inside square brackets. However, we need to ask ourselves, do these values also apply? Well, we're asking when is it less than 0. Right at -5, it's equal to 0. So we can't include those. And so there are the solution to the problem. Number 2. They give us additional information, but once again, all we really have to do is look at the graph. We're asking where's f of x less than 0? Well, I know all the way from -infinity all the way up to -3, and then it goes back below the line again at -2 until we get to 3, and then beyond 3 it goes on forever in the positive direction. So that are the only answers that we can get there. Now, graphically, it's pretty simple to see as long as the graph is somewhat accurate. But algebraically, what we need to do, or there's a whole nother set of things we need to do. So number 3, x plus 2, quantity x minus 2, and the quantity x minus 7 is less than 0. Now realize when we want to do this algebraically, what we're going to do is we're going to find the important points. And the important points are, when does this actually equal 0? And so one of the if it's already equal to 0, or if 0 is on one side, that's what we want to do. We want to find out when do each of these equal 0. So x plus 2 equals 0, x minus 2 equals 0, and x minus 7 equals 0. It's very simple to see x equals 7, x equals 2, and x equals -2. And what I'm going to do is I'm going to just put that on a number line. And I'm going to put in -2, 2, and 7, and put them in their appropriate order. Now what I'm going to do is I'm just going to pick a point somewhere down here, say -3. If I put in -3, what I get is negative, and all I'm really interested in is what sign, positive or negative. So -3 will be negative, negative, negative. Well, negative times negative times negative is negative. So I'm going to put a negative in that little area there. A good point to choose in here is 0. So if I plug in 0 here, I get positive, negative, negative. Well, positive times negative is positive. Now if I pick a point here, say 3, this will be positive, positive, negative. Positive times negative is negative. And then another point out here, say 8. Positive, positive, positive. Positive times positive is positive. And so now we are asking, when is this less than 0? Well, in other words, when is it negative? So it's going to be -infinity to -2, along with 2 to 7. And those are the only places where it's negative, and so that would be the answer that we are looking for. Number 4, we have x times x plus 3 times 5 minus x is greater than or equal to 0. Now the greater or the equal to part's just going to mean we're going to have some brackets instead of just parentheses. But let's see what we need to do. We need to first of all find the important points. Set x equal to 0, x plus 3 equal to 0, 5 minus x equals 0. X will equal negative 3 here, and x would equal 5 here. So on my numbered line, I have 3 important points. They are negative 3, 0, and 5, and they have to be in the appropriate numeric order. So I'm going to pick a value down here, negative 4. Negative, negative, positive. Negative times positive is positive. Pick a value here, negative 1. Negative, positive, positive. Negative times positive is negative. I'm going to pick maybe the value of 1 right here. Positive, positive, positive. Positive times positive is positive. And a number out here, say 6, positive, positive, and negative. Positive times negative is negative. And we need to know where is it greater than or equal to 0. In other words, where is it positive? So from negative infinity up until negative 3, and then from 0 to 5. Well, the equal to part means any place there's a digit, we can actually put it inside brackets, but we never put the infinity inside brackets. And number 5 is a little bit different because we have x cubed is greater than or equal to 27. Now realize with only the one x here, it becomes simple. What is our important point? Well, in other words, x cubed equals 27, so x will equal 3. So that's the important point. But now, what we have to realize is we can no longer do positives and negatives because we're not comparing it to 0. Instead, we need to ask, is it true or is it false? So I'm going to pick a point down here. 0 would be very good. 0 cubed greater than or equal to 27. No, that's false. So we put a false, and then pick like 4. 4 cubed is 64. Is 64 greater than or equal to 27? That is true. And so when you deal with falses and trues, then it would be from 3 to infinity. We know infinity will not be surrounded by a bracket, and since the equal to here, we have a bracket here. Realize we could do this as well. We could look at, okay, down here is negative 4. Negative, negative, positive. Well, that's negative times a positive is positive, and is a positive greater than or equal to 0? This would be true. We could also do true, false, true, false, and the trues would all be included and the falses would not. So it works either way, but when you've got 0, really all you have to worry about are the positives and the negatives. Number 6 asks us to use the graph to try and answer the question. And we're asked, where does f of x, or where is f of x less than or equal to 0? Well, it's rather obvious that it's below 0 between negative 3 and positive 3. And even more importantly is the fact that those are actual vertical asymptotes, so that means it will never reach those values, but it certainly will keep on getting closer and closer. So our final answer there is negative 3 to 3. And we will finish this section up in the next video.